Okay, so before I start this presentation, let me begin this with a story, which you may find very painfully familiar and relatable. Okay, so imagine yourself in a company called Zenflow Innovations, where you have an app called Focus Flow, which is a productivity app, and you have a major release coming up called Deep Work Mode. Lots of people are waiting for that. You have a client demo coming up within few hours, and your lead developer Nikhil has just polished up all the code and then uh, pushed the code to GitHub, and your CI/CD pipeline kicks in. The whole dance of pulling code, running the tests, integration tests, unit tests, building Docker images begins. And at one of the stages, you see a red cross, big red cross. What do you see? Integration tests are failed. So this is where Rahul, our release manager, starts panicking. He taps his foot nervously and asks Nikhil, what happened? So this is where Nikhil, who is a seasoned developer, doesn't panic. He says it must be just a flaky test, and then tries to restart. Tries to rerun the flow, and it starts running again. So all good till now. Then the team goes ahead to deploy that same code to production. They run the same pipeline, same tests, build, etc. And then after a while, the same step fails. So now this does not look good. They try to figure out what is going on. They try to go through the thousands of lines of logs to find out the issue. Our release manager is getting anxious. The demo is coming up in few hours. Time passes. This is where our DevOps engineer comes into picture. The DevOps engineer Priya, who excels in debugging these kind of issues, goes through the logs, but still it takes a lot of time for her to understand what is going on. This is where the team starts to become very anxious. Everyone tries to look for solutions for this issue, and finally, Priya is able to find that there is a small DNS issue which is acting like a ghost, making the pipeline pass or fail randomly. But by this time, the demo time is over, and the demo is delayed, and the whole release is delayed. So this may be a relatable story for a lot of you. I have certainly seen it before in my time. So this is where issues like broken pipelines, flaky tests, failed deployments, even communication issues between developers and operation teams, they create a lot of operational risk. Developers stop trusting your CI/CD pipelines. Even if something is green, developers can't trust the pipeline that the release will be successful in the future. Or if something fails, and even developers are still able to deploy some things, a faulty code to production. So they lose trust on the pipeline. There are a lot of development bottlenecks because of this, and the developers are eventually frustrated. So this is a common problem across organizations, especially before CI/CD, but during CI/CD as well. So this is where the SRE approach comes into picture. SRE approach to the CI/CD pipelines, not just for your applications. So first pillar of SRE is to accept risk and failure. You need to understand that things will fail. You need to minimize that. This is where observability comes into picture, which plays an important role. So you think from an observability perspective. You set out some SLOs just for your applications. You put some objectives, right? So similarly, you also put objectives for your CI/CD pipelines. I want my CI/CD pipeline to be successful 9 out of 10 times. So such kind of SLOs I put automation as much as possible, and I follow release engineering principles to deploy safer. So these are the topics I'll discuss in this presentation. I'll focus more on the observability, and then the little bit on the following topics. So why do we need observability in CI/CD pipeline? So first thing, if something fails, if my pipeline fails, I want to know why it failed. It should be able to tell me where it failed. It should not be giving me thousands of lines of code for me to parse myself. It should be able to give me what the exact issue is, where are the bottlenecks within the pipeline. That can be across, that can be for one run or multiple runs over a period of time. Are things getting worse over time? So there is a chance that one job today runs in 2 minutes. 1 month down the line, it may be running in 3 minutes. So you need to understand from your pipeline runs, historical runs, that are is the performance of my pipeline consistent and improving or not? And how often do transient errors occur? Just in the story that we saw, uh, how often transient errors are occurring? Am I able to reduce those or not? And what is the impact of change on the pipeline? So change as in the application change, as well as the CI/CD pipeline structure change itself. So what is the impact of those changes on the pipeline and the performance of that pipeline? So I want to get the answers of all these questions by the observability suite for my CI/CD pipeline. This where I'll also introduce OpenTelemetry. A lot of you might already know about it. So OpenTelemetry is an open source framework which is able to generate, collect, and export telemetry data traditionally for applications, but for CI/CD as well. It is vendor neutral, so you can plug and play a lot of different tools which are OpenTelemetry compatible, different languages for you to generate these telemetry data, and different tools like Grafana, Signos, etc. to consume all those data. And it is a unified standard across the open source community. It's a CNCF project, and it builds on top of three type of pillars: metrics, logs, and traces. I believe which was already covered in some of the sessions before. So this is how bit on the OpenTelemetry, how you go about deploying and using OpenTelemetry. So OpenTelemetry provides a collector and a set of SDKs. So depending on the languages and tools you are using, you can use those SDKs to generate and export logs, matrices, and traces in the OpenTelemetry format and standard. And you can use the collector to perform batching and refining and sampling all those telemetry data before sending it to the backends. So collector you deploy closer to your systems where the logs are being generated, logs and matrices and traces are being generated. So you can either have the OpenTelemetry SDKs directly send data to your backends, such as let's say Prometheus for metrics or Loki for logs, etc. So that is the very simple implementation where you have OpenTelemetry SDKs and you're using those to send data to your backends. But that will have a lot of network latency introduced in your application, performance issues introduced in your applications. That's where different type of deployment formats are there for OpenTelemetry collector, where you have the collector deployed as a daemon set in each node if you are using Kubernetes cluster, or each of the VMs if you have VM-based applications, and even as a sidecar in your pods. And then there is another approach where you have a centralized OpenTelemetry collector, which all your services are using to send the telemetry data. You can also use the combination of second and third. So quick offloading of your telemetry to OpenTelemetry collector running as sidecars, and then sending it to a central collector for all the batching and filtering and other operations, even masking if required. So that's how. There's a quick intro on OpenTelemetry and OpenTelemetry collector. For CI/CD use case, you may have a number of CI/CD platforms. I've given Jenkins, GitHub Actions, and GitLab. So you can use these platforms to generate the matrices. These platforms will be generating matrices and logs and traces, which you can use. OpenTelemetry SDKs you can use to send that data. Jenkins also comes up with a OpenTelemetry plugin, which integrates very easily to send the logs to a collector, telemetry to a collector. And then OpenTelemetry will use different backends, such as Prometheus for metrics, Loki for logs, and Jaeger for matrices. And then you can use all these different backends in your visualization tool, so Grafana, Datadog, etc. Or you can skip all this and you can just send data to a backend which accepts different type of telemetry formats and also supports visualization. So one of the examples is Signos, which is also an open source tool. Here, I'm sending telemetry data from my CI/CD applications as well as my applications and microservices. So this is where I have a unified way of collecting matrices and traces in a single plane of class, where I can correlate between different stages, with different jobs, also between what I have deployed and what is running in the system. So I can correlate all those matrices, and then if any issues arise, I am able to able to uh, troubleshoot easier. So when implementing any kind of observability, you need to understand how to instrument uh, the data, so how to instrument your systems. So for CI/CD, we will look into two things: how to collect and what to collect. So how to collect part, I have already mentioned that you have OpenTelemetry SDKs available for different languages and as plugins for different platforms. So these are the two ways. There, OpenTelemetry also provides you with uh, auto instrumentation for some of the languages, so that you don't have to start from day one on modifying your code. Instead, you can just use auto instrumentation, and then gradually you start feeding into custom data. This is a end job of a Jenkins pipeline in the Groovy format, where at the end of that pipeline, it is creating a span and a meter for metrics, and then sending the pipeline status uh, to the appropriate backend using the OpenTelemetry collector. So here I have the OpenTelemetry collector already configured within Jenkins, and this code snippet, this job within the pipeline is using those details. And second piece of instrumentation is what to collect. So for logs, matrices, and traces, each log will have a timestamp, will have a log level, it will have some message, commit ID, and job name. Apart from that, job and stage name. So those are all CI/CD parameters. You'll also have trace and span ID, which will help you to correlate it with other type of pillars of observability. So let's say you find a metric, you have a graph based on a different metric called success failure count. So or success failure of a job. So you look something failed in the graph, you click on that graph where your pipeline failed, and you will be directed to the exact log where it failed. So this correlation can be possible using trace ID and span ID. Uh, at the metrics end, you can collect information like execution time, success failure count, queue duration, so how long a job is being queued before it starts running, artifact size that you're storing within the steps, and upload duration. Similarly, for traces also, parent span, child span, and any nested span that you have. Collecting data is one thing. Second is a visualization of that data. So you'll need to visualize different type of matrices and gain information from it. So there's a very common framework for visualizing open source DevOps pipelines, CI/CD pipelines. This is called DORA framework. So this is where you collect 4 type of information: deployment frequency. So how often a team is deploying code to production. So you count it usually as deployments per day. So all the mature teams, elite teams, deploy more than once per day at least, or multiple times per day. Uh, So that you can see the trends of those deployment frequency. Second is lead time for change. So what is the time difference between when a developer committed the code and when it went to the production? So that also measures your development velocity and efficiency. Second is time to restore. So if, let's say, if something fails, how long it takes for you to fix that using a hotfix or using another release. So the time to restore you can collect from the your integration test. Let's say if those failed, you can consider that as a failed metric, and then you can look for the next release and the time between those. You can calculate as the time to restore. So you can time to restore. You can also have view on mean time to restore. So MTTR, and you have change failure rate. How often deployments are getting failed. So uh, I've lead time for change should be lesser than 1 hour for all the mature teams. Time to restore should also be very less. Similarly, failure rate should be, you should target something between 0 to 15% at max. I've already talked about some open source tools for visualization and creating these dashboards. If you are using GitHub, it also provides some visualization out of the box. Let's say first one is being average job runtime, how long a job is being queued before it starts running. So this is a very good metric which tells you when you need to scale up and scale down your runners, so that you have faster CI/CD pipelines without any unnecessary wait for jobs. Job failure rate and failed job count. So this is from a common open source repository uh, which had quite good data. Other similar dashboards you can build for version control as well, and for CI/CD metrics in terms of build duration and all. So this was on the observability of CI/CD pipelines. Second piece, I'll move to designing for reliability. Okay, so when you are designing for reliability, like I mentioned, you need to accept that failures are inevitable. They'll happen now or some other time, but they'll happen for sure. 100% uptime is impossible or very expensive. You will not get the budget for that. So some things that can go wrong for CI/CD pipelines, like we saw in the example, the DNS timeout was one issue. Network blips can be an issue. Let's say your CI/CD pipelines are talking to third-party services. That service may be down or may be unresponsive for some time. So there may be resource contention. So a lot of CI/CD pipelines running at one time and are racing for resources. And you may have some unreliable tests which are uh, which fail sometimes, which pass sometimes. So those things will be an issue. So how do you make your CI/CD pipelines more reliable? So there are four things I've mentioned here. One is idempotency, checkpointing, automated retries, and graceful failure handling. So idempotency is, let's say I have a job that I'm running, and for some reason I run it again. It should have it should not have any extra uh, effect from the first run. If the first time it is successful, even if I run it again, it should have the same effect. If first time it failed, and if I run it again, it should have the same effect. Not as in like failed effect, but it should not create uh, different outputs from what it is supposed to be. So, for example, consider Terraform pipelines. So, if you have a Terraform code base which you have not changed across, so basically a single commit, you run it once, there may be some issues in terms of quotas at the cloud provider's end, and it does not run. You try to run it again, it should be creating the same resources. If you write Terraform code in a way that I'm putting some random values in a bucket name, so if I run it multiple times, it will create multiple buckets in each run. Instead, you need to ensure that your pipelines are idempotent, so they have the same effect. So across runs, I have the same bucket names. Some random prefixes are not different across runs. Second is checkpointing. So for bigger pipelines which run for, let's say, hours or take a lot of time, so in such places you need to checkpoint all the successful jobs, and if something fails, your developer should be able to restart from that failed stage or job instead of starting from the beginning, because it has a lot of compute restrictions, and also consumes a lot of time. Then automated retries, it's a you may be against it, or you may be for it. So that's where automated retries should be done for jobs which are idempotent. If you don't want to automatically retry jobs which are not safe to do so. So that's where automated retries are essential if for maintaining reliable pipelines and graceful failure handling. So this is where clear error messages, etc. are okay. I'll move forward. Performance optimization. So why fast CI/CD matters? Everyone, I believe, like faster feedback loops, faster development, and more frequent commits, etc. But how do you make it fast? So caching is one thing. So let's say your Docker images, you want to cache those things, uh, different layers of the Docker images, node modules, etc. Artifact management, you need to store artifacts in appropriate places instead of storing blob storage. You should store each type of artifact in their respective artifact tree. Let's say Docker for Docker registry, or container registry, Helm for in a Helm artifact tree. Similarly, node modules in a npm registry, and parallelization for all the exclusive tasks within your CI/CD pipeline. Security is another thing. So for security, there are different. I believe in one of the previous talks, all the shift left mechanisms were already discussed. Skip that. But what all you can have in the CI/CD pipelines is, so first thing is SAST, where you are doing static analysis of the code, for looking for any vulnerabilities in your code. Let's say exposed API key, etc. Then there is software composition analysis, which is doing vulnerability checks uh, on your dependent libraries. We use a lot of open source libraries, so we need to ensure that those are also safe to use. Container image scanning. So this is where you need to scan images for, again, for vulnerabilities. There are tools I have mentioned already here. Then infrastructure as code. So let's say you don't want any public buckets within your cloud organization. You don't want any public firewalls exposed directly to internet for certain networks. So such things you need to you can ensure using ISE and KTS manifest scanning. So implementing OPA, etc. Then dynamic application testing. So this is where your applications are tested in a running environment. So either a temporary environment or a non-production environment, where this testing basically tries to uh, run malicious requests against your running software to test this application. And then code signing and verification. If you have installed, basically doing verification of the software at the client end, uh, that the code is actually from the desired producer. So coming back to observability, you can build observability matrices around the security that you have implemented in your pipelines, and have actionable workflows created based on certain thresholds and certain matrices. Um, so based on the different tests that we have seen here, you can create different different dashboards here. Then data-driven deployment. So basically, if something fails, you monitor those key indicators. You actually see in your graphs. So if any SLOs are broken, either you get alerts for manual rollbacks, etc., or you can, like, at the final stage, I would consider is you have a dashboard where the dashboard itself has a button which you can click to roll back if something fails, or even if there is an automated alert, and if it is a application that you can automatically roll back from your dashboards without even clicking anything or without any user going to the dashboards, that would be the best scenario. So if any SLOs are broken, you would want to roll back, and then the automated rollback and will happen from your observability suite itself. So the key takeaways from this is treat CI/CD systems as critical, just like your production applications, uh, where deep observability will be the key. Uh, you uh, you design your CI/CD pipelines using all the patterns, reliability patterns that I've discussed. Uh, Optimize for speed and efficiency. So that will make your development culture, your developers make faster commits and ship features faster. Then security is another essential tool. You need to shift left to the CI/CD pipelines instead of thinking security as an afterthought. So you catch all those vulnerabilities early. And CI/CD is one of the best place where you can implement, but you can also do at the IDE level. A little bit difficult to enforce that, but uh, lot of these tools that I have mentioned can also run on an IDE. Uh, then finally do the data-driven deployments. So based on the matrices and observability dashboards that we have seen, the deployment should be adjusted accordingly. Sorry if I've rushed a lot. Next steps, I wouldn't. I think I have covered a lot of things, but I do not expect that everything can be done in one go. Just like I said, like start with an auto instrumentation and then start customizing those matrices yourself. So start small, look into the observability, then start looking into the security. Maybe start with one type of security testing, one type of reliability pattern, one type of start with metrics, let's say, then put logs, then put traces, etc. So I believe, I think experimenting and exploring would be the way to go from here. Thank you so much.
Questions?